Track spacing. Track spacing is the distance between the track centers of double-track railway lines. There are standard distances derived from the standard loading gauge in a country. For high-speed trains and in tighter curves, that distance needs to be increased. The track spacing is also called the center-to-center spacing to differentiate it from the edge-to-center spacing of a railway. These two values may be different depending on how signal masts are added to the overall track geometry. Description. The distance between the track centers makes a difference in cost and performance of a double-track line. The track centers can be as narrow and as cheap as possible, but maintenance must be done on the side. Signals for bidirectional working cannot be mounted between the tracks, so must be mounted on the wrong side of the line or on expensive signal bridges. Track centers are usually wider on high-speed lines, as pressure waves knock each other as high-speed trains pass. The minimum track spacing can be derived from the loading gauge. The European bone gauge has a width of 3,150 mm. The minimal distance to structures on the side of the track is half of it, but that is doubled again for double-track lines. As a wagon can move within the rail gauge, one adds 100 mm, and with a possible displacement of tracks over time, one adds some 250 mm as a security margin. This leads to a minimum center-to-center spacing of 3,500 mm. In fact, the first Prussian railways were built to this standard, but it became soon apparent that it was too dangerous, with some passengers having a hand or their head out of the window. Narrow track centers might be 4 meters or less. Narrow track centers may have to be widened on sharp curves to allow for long rail vehicles following the arc of the curve, and this increases the surveyor's workload. Widening a track center to 5 meters or so suits high-speed trains passing each other and eliminates the need to widen the centers on sharp curves. Increasing width of track centers of 6 meters or more makes it much easier to mount signals and overhead wiring structures. In the United Kingdom, the early lines of the Great Western Railway were built to Brunel's broad gauge, which was also associated with a more generous loading gauge. This is still apparent along those lines which remain in use today. Structures such as bridges and tunnels are larger, and the distances between opposite platform faces are larger. Very wide centers at major bridges can have military value. It also makes it harder for rogue ships and barges, knocking out both bridges in the same accident. Railway lines in desert areas affected by sand dunes are sometimes built on alternate routes so that if one is covered by sand, the others are still serviceable. If the standard track center is changed, it can take a very long time for most or all tracks to be brought into line. Regulations. The general standard in Germany and Switzerland had been to build new tracks with a center-to-center spacing of 3.80 meters and a spacing of 4.50 in railway stations. Depending on the usage of the tracks, it was still possible to build new double-track lines with track centers of just 3.50 meters. With the trains going faster over time, the track centers were increased to 4.0 meters on main lines. The advent of high-speed trains required a stronger regulation, which was regulated in Germany's EBR. The first update of 1982 increased the minimum track center to 4.0 meters, allowing no more exceptions. But by 1991 it was replaced with a table taking into account the maximum speed of the trains on the track as well as the curvature. A distance of 4.0 meters was considered enough for speeds up to 200 km/h. At 250 km/h the tracks have a center-to-center distance of 4.50 meters, while the first tracks in the 1980s were built with a distance of 4.70 m. The TGV track construction puts both rail tracks into a common concrete block so they can disregard a safety margin for track displacement. This allows high-speed rail to have a center-to-center distance of just 4.20 meters. Additionally, these lines are only allowed for high-speed passenger rail where no out-of-gauge loads are expected and the windows in the trains cannot be opened. In Japan, the first high-speed tracks of the Central Japan Railway Company Shinkansen were built with a distance between track centers of 4.3 m. The largest minimum track center is planned for India's high-speed network, requiring a common distance of 530 m. Track center examples. Put in order of size: 9-foot Liverpool and Manchester Railway 1830 opening day, later widened. 10-foot United Kingdom is 6-foot plus a 4-foot 11-foot New South Wales 1855 old standard, estimated 12-foot New South Wales 1910 new standard for 10-foot wide carriages. Rounded in Imperial. 13-foot New South Wales 1973 metric standard, rounded in metric. 14-foot New South Wales set knock lines after about 2012. 4.20 meters LGV Rhone Alps 4.23 meters Takeda Shinkansen 4.30 meters Sanner Shinkansen 4.50 meters Erfurt Leipzig/Halle High Speed Railway 4.70 meters Nuremberg Erfurt High Speed Railway before 1998. Measurement. By definition, the track spacing is given from center to center of a rail track. For an actual construction, the distance is measured from the inside of a railhead to the matching one of the other track. As far as both tracks have the same gauge, this is the same distance. Sharp curves. Track center may need to be widened on sharp curves. Gauge may also need to be widened, requiring special sleepers if made of concrete. Accidents. If track centers are narrow, then a problem on one track may affect other tracks. This is called a common mode failure. It affects railroad and canals. River accident damages bridge in both directions. In the 2020 Wallen accident, 3 of the 4 tracks were blocked by the derailed train. 2021 got derailed crash, second train collides into already derailed train on other track of double track line.